Good day to you. This is teacher Leland, Alejandro, and we're going to discuss today complex numbers. And under complex numbers, we will be doing graphs and absolute values of complex numbers. So we're going to check on the problem sets right now. Okay. All right. Here's the first number. Now let's determine the number of items that we're going to do today. Okay, we have here about probably around 20. Yes, 20 numbers. Now the first part will be locating the specific dot or point, okay? And then for the second part, from the points, we will have to identify the particular number, okay? Complex number. And then for the third part, we're going to compute the absolute value of any complex number. Okay, so let's begin with the first, with a very first number. Graph each number in the complex plane, and we shall be using a presentation view. Okay. Graph each number in the complex plane. Okay, so the location of a number is like represented by the x and y point or x and y coordinates, where the x-axis represents the real number part and y-axis is representing the imaginary number. Okay, so for the ones with the I, that will be for the imaginary axis, okay? And then the real number without the I, that will be for the real axis or the x-axis. All right, so for the sign rules, it follows the Cartesian coordinate system, where the first quadrant, both positive, x and y, okay? In this case, the real number and the imaginary number are both positive. If the real number is negative and the imaginary number is positive, that would be for the second quadrant. And if the real number is negative and the imaginary number is also negative, then that will be for the third quadrant. Now, if the real number is positive and the imaginary number is negative, that will be for the fourth quadrant. So it follows the rectangular coordinate system. All right, so let's have the first. This is negative for 2i, so that should be over here. Okay, there. You can check on the blue dot that I placed. All right. Okay, that's the answer. Okay. Now we can verify that by the computer. Okay, the computer's answer is red. There. Okay. All right. Our answer is blue. Okay. All right. There. Okay. So let's. That's it for the first number. Let's proceed to the second. Okay. Here is the second number. Okay, graph each number in the complex plane. This is only a real number part. There's no imaginary part. So just the same, we can plot this. This must be at this location. There, okay? That is the -5. And we can verify that easily. There, okay? Okay, you can see the red. All right, I think I covered the red. All right. Okay, so that's the answer. You can see it blinking. Okay. All right, there. Okay, that's for our number 2. Let me remove my answer so you can see the red. Okay. There. All right. So exactly where I placed the blue point. All right. Let's continue with the third. Okay, here's number 3. Here's the given complex number, -2 plus 4i. So where's the location of -2, 4i? Okay, I'll show you. It will have to be at the second quadrant over here. There, okay? That's the location. And we can check that. There, you can see the red, okay, and the blue together. That means we identify the correct location of the complex number in the rectangular coordinate system. Okay, let's have the next. Let's proceed to the next. Let me remove this blue. All right, graph each number. We have 1, -5i. So the real number is positive, the imaginary number is negative. This should be at the fourth. So this should be at the fourth quadrant. It must be somewhere here. There. Okay, that should be the location of 1, -5i. Okay, so we shall verify this. There, okay, you can see it. So that means we're correct. This is the way to graph the complex number. All right, let's continue with the next. Let's proceed to number 5. Graph each number, the complex plane, what and where is 5i? Where is 5i? This is imaginary number, and this must be at the y-axis part on the positive side. So it must be over here, 5i. Okay, it must be right there. Let me make my point nicer. Okay, so it must be there. Okay, so tiny. All right, I hope you can see that. That's the small blue there. Okay, small blue point. Let me make it larger. There. Okay, and here comes the answer. There's the red. Okay, there's the red. Okay, so that's it. We're correct. 5i is the imaginary part of a complex number. All right, so let's continue. Let's have the next. Number 6. Okay, here. Graph each number in the complex plane. 3, -5i. So where is 3, -5i? That should be at the fourth quadrant. It must be over here. There, okay? That is 3, -5i. And we shall verify this. Okay, so it's correct. All right. Next, we shall continue with number 7. Here's number 7. For the next numbers, we will be identifying the number, okay, given the point, okay, or the graph. So identify each complex number that is graphed. All right, so for number 7, we can see the black dot at the second quadrant. So it must be -2. -2 for the real part and +5i for the imaginary. +5i. There. So this must be the answer. And we shall verify it there. And you can see the answer over here. So it's -2 plus 5i. So given a point in the complex plane, complex number plane, okay, you should be able to identify the number, okay? All right, so the answer is -2 plus 5i. All right, let's have the next, number 8. Let's have number 8. Okay, here's number 8. Identify the complex number. Okay, it's located at the third. So this must be -2 and another negative, okay? -2, -5i. There, okay? And we can verify the answer. There, it's -2, -5i. All right, you can see the red answer over there. All right. Next, let's have number 9. I hope you're getting the way to do it. All right, so let's have number 9. Identify the complex number. Okay, this must be at the second quadrant. This must be -1 plus 3i. Okay, so this is -1 plus 3i. There. Okay. All right, let's verify. You can verify the answer. Okay, it's there. It's -1 plus 3i. So this is basically reading. Okay, you should be able to identify, and a while ago you should be able to determine the location given the number. So this time we're doing the reverse. All right, so this is for number 9, and we are correct. Okay, let's have number 10. Let's have number 10. Next number is number 10. Okay, identify a complex number graph. All right, it's located at the 4th quadrant. This looks like positive 2 minus 5i. So it's a positive 2 minus 5i. There. Okay, so this must be the answer. Let's verify the answer. The computer can show us there. It's 2 negative 5i, and you can see it over there. Let's do number 11. Number 11. Okay, here's number 11. Identify each complex number graph. It is located at the 1st quadrant. The point is located at the 1st quadrant. Okay, you can see it at the 1st quadrant. So this must be about positive 5, positive 2i. Okay, so this is 5 plus 2i. There. Okay, and this is our answer. How about the computer's answer? Let's see. There. Okay, same as the computer. It's over here. So we are correct. All right. Let's proceed to the next. Let's have number 12. Number 12, after I remove this. All right. Okay, here's number 12. Okay, you can see the black dot, all right, down here, okay? And there's no real number. That means there is no real number. So this will have to be just negative 5i, okay? So this is just negative 5i. This is the answer, okay? And we shall be able to verify this there. And we're correct. Very simple, okay? So you just have to make use of the axis, okay? All right, let's have the next. Let's have the next number. Let's have number 13. Okay, we're now doing absolute value for the given. Okay, now the formula for the absolute value, you just have to make use of this formula. The absolute value, okay, make use of this. The absolute value, let me check on this one. Okay, the absolute value of a complex number like this is equal to the square root of the square of the real number, okay, plus the coefficient of the I, okay, which is the B, there. Okay, so this is comparable to the Pythagorean theorem, okay, Pythagorean theorem. So this is the formula, A plus BI. The absolute value of that is this. Okay, so you're going to use this formula all throughout to determine the absolute value of a given complex number. Okay, so don't forget this formula. Right, let's do the first example, which is number 13. Okay, here's the given. We have negative 2 plus 9i. What is the absolute value? There, it's already indicated. What is the absolute value? This is going to be the square root of 2 squared. That happens to be a negative 2, okay? But when you square it, that becomes positive. And you have the 9 squared. So this gives us 4 and 81 under the square root sign. And this will have to be square root of 85. Yeah, and this must be the answer. Square root of 85. And we can verify that. And you can see it over here. There, square root of 85. So I hope you were able to make use of the formula that I wrote first. All right. Let's have the next, number 14. Let me clear the screen. All right, let's have number 14. Okay, here is number 14. Okay, all right. So this is absolute. What is absolute of 10 minus 4i? There. And this is actually the square root. Okay, the square root of negative 10. I will not write the formula anymore. I will just get the numbers and then I will show you how it's done. Okay, that will be squared and you have the negative 4 and you will have to square that there. Okay, so when you square these numbers, they will be both positive. Okay, they will become both positive. Now, to make computation simpler, we can get common factors for each. Remember that 4 has a 2 because 2 times 2 is 4. Also, the 10 has a 2 because 2 times 5 is 10. Okay, so we can actually simplify our computations. Okay, all right. Since when you square these numbers, negative 10 squared, that will be a positive 100. We can actually go into it as if there is no negative. Okay, so we can just write there 2 and 5. Okay, and then you're squaring it like that. And this is also 2 times 2. And then you will square it like that. Now, notice you have a common number 2, okay? And when you square this will become 4. And then the number beside it, which is 5, will become 25. And added to 2 squared is another 4. And the other 2 will be another 4, like that. Okay, so you see there is no more negatives there, okay? Because when you square these numbers, after all, they will become positive. Okay, now let us have that common factor 4, okay? And factor out. And then we will have the 25 and the 4, okay? Take note, we move out the common factor. And this will still be under the square root sign, like that. And so this is now square root of 4 times 29, okay? So you have here square root of 4 times 29, there. And in algebra, you can split this to square root of 4 times square root of 29, which is actually 2 square root of 29, there, okay? So our answer is 2 square root of 29, there, that's our answer, okay? All right, that's the answer for number 14. So let us verify. Okay, you can see it over here. The answer of the computer is in red color there. 2 square root of 29. So I hope you were able to see how it's done, each step. Okay, you should be able to take note of the steps of this. Well, you need a little idea about getting common factors and perfect squares. Okay, so perfect squares like 4. Okay, the one we factored out, 4, and then 9. What else? 16, 25, 36, 49, 64. Those are the perfect squares. So it helps in the simplicity or simplifying your solution. So that gives us our number 14. Let's continue with number 15. Okay, let me just clear the board, the screen. Let's continue with the next number. Here's number 15. Find the absolute value of each complex number. Okay, we have the given. So let's start with the given. You have the negative 10 plus 5i. This means the square root, okay? You have here negative 10 squared. That's for the real number part. And then plus, take the 5. That's for the imaginary part coefficient. Square it there. Okay. Now, we can assume these two numbers will now be becoming positive. And we have a common factor again, the 5. Okay, the 5. There is 5 in number 10. 2 times 5 is 10. So we can assume this number now as a positive number, and we can have the 5 times 2. And then this will be squared. Okay, you can ignore the negative sign because after all, when you square that, that's a positive. And then this is now 1 times 5. Okay, and then you have their squared like that. Okay, now we're going to square now. 5 will actually be 25. And the 2 squared, that will be a 4. And the 1, when you square, that will also be 1. And the 5, when squared, that's another 25 there. And this is under the square root symbol. Okay, factor out now the 25, the common number 25, like this. And when you do that, the remaining two numbers will be the 4 plus 1 there. And this will now be square root of 25 times 5 there. And so we can now split this into square root of 25 times square root of 5. And finally, our answer, that will be 5 square root of 5. That's the answer, 5 square root of 5. And we can verify that over here. There. Okay. All right. So that means we're correct. And we shall continue with the next number 16. All right, let's continue with the number 16. Here's number 16. Find the absolute value of each complex number. We have the given. Find the absolute of negative 9 minus 6i. Okay, so we'll only be using the negative 9 and the negative 6. Okay, we have the negative 9, then we're going to square it, plus, okay, and we have the negative 6, and we're going to square it. There. Okay, since there is an involvement of negative 1 there, and when you square negative 1, that will still be positive. So you can now ignore those negative. Now just think of 9 and 6. 9 has a 3, and 6 has a 3. So we can split the 9 into its factors, 3 times 3, and then squared. And we have 2 times 3, or 3 times 2, that will be for the 6 squared. Okay, there. Now, we have a common number. Always think of that common number, okay? And for this example, it's the 3. So when we square these numbers, we will have 9 times 9 and 9 times 4. There. And now we have a common factor 9, which can be factored out. What remains inside will be 9 and added to 4, like that. And this will become a square root of 9 times 13, which gives us square root of 9 times square root of 13, which gives us the final answer, 3 square root of 13. So the answer is 3 square root of 13, okay? So the answer is 3 square root 13, and we can verify that there. And you can see it over here. So it's 3 square root of 13. And that goes to our number 16. I hope you were able to follow the steps. And let's continue with the next number, 17. All right, here's number 17. Find the absolute value. Okay. 8 plus 10i. Okay, so this is 8 plus 10i. And this will be the square root of 8 squared plus 10 squared. Okay. Okay, what should be a common number between 8 and 10? Common number is 2. So we can produce 2 times 4. That goes to our 8. And 10 has 2 times 5. And that will be squared there, under the square root sign. Okay, square now the numbers. We have 4 times 16, we have 4 times 25. There. And we now have a common number 4. That becomes our common factor. We can factor out, and then we will have 16 plus the, what is that? 25, okay? 25. There. And so this will be under the square root sign. All right, so this will actually become square root of 4 times, how much is that? 41, okay? So we have square root of 4 times 41, which gives us square root of 4 times square root of 41, which is reduced now to square root of 4 is exact 2. And then square root of 41 remains square root of 41. And this must be the answer. All right, let's verify. Okay, all right, it's over here. That's 2 square root of 41. That happens to be our answer. Okay, so I hope you were able to follow the steps. And we still have a few more examples. Let's the next. Let's have number 18. All right, here's number 18. Find the absolute value of negative 6 plus 2i. Yeah, let me make that I nicer. There. Okay. So negative 6 plus 2i, we will get the real number negative 6, and we're going to square that. We will get the 2, the coefficient of the imaginary number I. And here we have 6 and 2. And we have a common number between 6 and 2. It's a common number 2, okay? 6 has a 2 because 6 is 2 times 3. 2 is 2 times 1. So we can rewrite this like 3 times 2 squared. You can ignore the negative sign. And here is 1 times 2 squared. All right, there. So when we square this, we're going to have 9 times 4. We have 1 times 4. There. We now have a common factor, 4. We can factor that out. What remains will be 9 plus 1. Yeah. Okay. And so we now have square root of 4 times 10. And this is exactly square root of 4 times square root of 10. And final answer is 2 square root of 10. That's it, okay? So that should be our answer there. And we can verify this there. You can see it clearly over here. That's 2 square root of 10, exactly what we have over here. Okay, so again, you should be able to follow those steps there, okay, step by step. A little algebra there. All right, this is actually involving factoring. All right, let's have the next number 19. We have 2 more numbers. All right, 2 more numbers. All right. Let's have number 19. Okay, here's number 19. Find the absolute value of negative 4 plus 5i. This is the square root of negative 4 squared plus 5 squared. And we have here 4 and 5. This time we don't have any common number. Okay, we don't have any common number except 1, which is actually, we will not be able to make use of 1. All right, so this will be directly squared 16, and 5 becomes 25 under the square root sign, okay? Under the square root sign. And so this will just be square root of 41. There. That's square root of 41. And so this is now the answer. All right. Over there. Okay. Square root of 41. All right. We are correct. And we shall have the last number 20. So all you need to do is just rewind the recorded discussion, and you should be able to review and learn from it one by one. Okay. All right. You don't have to be very, very fast. You can do it one by one, slowly. All right. Let's have the last number. Here's the last number. Okay. Here's number 20. Okay. Our last number. Find the absolute value of -3 minus 6i. Okay, so we will make use of the square root of -3 squared plus -6 squared. There. Okay. Do we have a common number? Yes, we do. The 3. Okay. 6 has a number 3. So that's 2 times 3. So we have a common number here. So we will take 3 times 1 squared. That represents the -3. And this will now be 3 times 2. Okay. Remember, we're squaring the number, so you can ignore the negatives. All right, there. Okay, so we will now have here 3 squared, that's a 9. 1 squared remains 1. 3 squared, 9. 2 squared, 4. There. And so we have a common factor, 9. We can factor the 9. And we have 1 plus 4. There. And so this is square root of 9 times 5, which is exactly square root of 9 times the square root of 5. And this is now exactly 3. The square root of 9 becomes 3. Square root of 5 remains the square root of 5. And that's our number 20. All right, over here, there. That means we were able to do all the numbers correctly. Okay, and I hope you were able to learn all these 20 numbers. And if not, you can always go back and rewind the tape. All right. Okay, so that will be it. And we'll be discussing more in the future. Okay, this will be all for now. This is Teacher Leland. Bye-bye.